Okay, good afternoon, and welcome to the 7th webinar organizing the European project BovINE. I am Virginia Resconi from the University of Zaragoza in Spain, and together with Jakeline Romero, we lead the thematic area Production Efficiency and Meat Quality from BovINE. And we thought that this webinar could be of your interest. So today we will listen and discuss about feed efficiency in cattle, why feed efficiency is important, what makes the animal more efficient, how feed efficiency is measured, at what cost, is it well implemented in Europe, is there a relationship between feed efficiency and methane emissions? So our guest experts, Lisa Rumsfeld, Pablo Guarnido, and Paul Smith, will try to cover these questions in their presentations. And at the end, we will have some time for discussion. So we would love to read your questions and comments in the chat box. Sinead Waters and José Pais will join the roundtable together with our three panelists.
Good afternoon. I am Jakeline, and I thank you for joining us today. So, we will start with Lisa Rumsfeld. Lisa is the Vice President from Vytelle, a precision livestock company. And in approximately 5 minutes, Lisa will explain why she thinks feed efficiency is important. Then, Pablo and Paul will share their research results, and Lisa will close the session explaining how feed efficiency is measured. Lisa, it's a pleasure to have you with us in this webinar today. We are ready to hear your presentation.
Great. Well, thanks for having me. And I'm really happy and honored to be on this webinar with such a great panel. So I look forward to the discussions that we're going to have. So 5 minutes to kick off why feed efficiency matters. I think I always like to talk about the global market landscape and how it's changing. There's a lot going on here. Our consumers, they are much more involved in what we're doing. They want to know how we're producing, where animals are coming from, how they're being treated. You know, the barn doors open, as we say. Sustainability, well, it's not a buzzword anymore. We are in a situation where we're have to explain to people and verify to people about how we're actually producing beef. There's lots of integration going on, be it coordinated supply chains, vertically integrated supply chains, and beef on dairy integration happening. We see new trade agreements emerging in the EU that are putting pressure on historical costs and trade agreements. Again, traceability, digital verification and validation into how we're producing our foods. And yes, we have competition from non-animal protein that are in the supermarket shelves today. So this visual is really to say why all this matters. We need new solutions and we need new tools, and we can't keep our head in the sand and think that all of these challenges are going to go away. We know that genetic progress is a proven solution, and if we look at what has been done on the beef side versus the chicken side over the last 100 years, the people in the chicken industry have improved efficiencies over 250% over the last 50 years, and they've done that through breeding and genetic selection. The slide on the right here shows you where we stand in terms of feed conversions. In terms of feed conversion ratios compared to what our colleagues do on the fish industry, in the poultry industry, and in the swine industry. Our feed conversion ratios haven't changed. And at Vytelle, we package these challenges up, what we call the triple challenge. And so that means having to produce more protein, do this in a sustainable manner, and look after our profits as producers. There's been lots of research out there that will validate why feed efficiency matters. We know that 70% of all of our production costs are related to feed. There's been research that shows us that we can improve gains when we're feeding cattle out. And if we do that and improve those gains by 10%, we can improve our profitability by 18%. However, by focusing on a 10% improvement in true feed efficiency, we can improve our profits over 43%. Beyond the general research that's out there, what I did in preparation for this webinar is I took a look at what's in the Vytelle multi-breed database that we've curated over the past 30 years. And up here, you can see what our average feed conversion ratios look like over 50,000 animals in our database. And I think really the take-home message here is to say that if we start measuring and selecting for feed efficiency, we can actually find those gems that are out there in our herds. We can improve feed efficiency. So ladies and gentlemen, change is truly possible if we start measuring and selecting for feed efficiency. So in my short wrap up here, I would bucket out why feed efficiency matters in saying, you know, we can measure and we can reduce feed intake, which is going to directly impact our costs. So we're going to be able to increase our profits. We're going to be able to run more cattle on the same amount of land with those feed efficient cattle. And Paul will talk about it in more specifics about the link between measuring and selecting for feed efficiency and its impact on things like methane. So with that introduction, I think I'm going to pass the baton back over, and you'll hear a little bit more from me in the webinar about actually how we're measuring feed efficiency.
Thank you, Lisa, for the introduction to the topic. So now is the turn of Pablo Guarnido to talk about the biology behind feed efficiency. So Pablo has grown in a family of beef cattle farmers in the south of Spain. He just finished his PhD in France, and now he's working at the Agrosup Dijon in France. Pablo?
Yeah, good morning, everyone. I think I'm now sharing my screen. Yeah, well, hello, everyone. My name is Pablo Guarnido, and today I'm going to talk about which are the main biological determinants explaining feed efficiency in beef cattle. So, first of all, I would like to summarize, to tell you why researchers started studying feed efficiency some years ago. Main reason is because of the continuous increase of human population, which influence higher food and protein demand, and therefore an increase in animal production and its intensification, which in addition have the higher ingredients price increasing since the last 10 years ago. Well, that's why in the last report of the FAO was determined that feed efficiency must be improved in animal production. And the two main ways to improve feed efficiency were, first of all, nutrition, feed, and second one, genetic selection. But now, in this moment, genetic selection is the main one because of feed and rationing improvement have been largely developed in the past in the research, and now we have many additives, many feeds, many type of rationing, improving feed efficiency. So now main companies are currently working on genetics. So to people no expert in genetic selection, I just want to tell you that company usually use genetic index to characterize animals and establish genetic correlation and be able to choose which are the best animals in a herd. Well, however, feed efficiency is a multi-trait character. So genetic selection for one feed efficiency index may be associated to other performance influencing animal nutrition, such as robustness, meat quality, reproduction, immunity. So that is why I'm talking in this conference today to show you a little bit which are the main biological determinants explaining feed efficiency, right? So now let's go to talk about some genetic indices and currently working or being used in genetic selection. In one way, you may know the first group of feed efficiency indices. They are indices related to gain. So feed conversion efficiency, feed conversion ratio, or residual gain. Well, these indices are genetically and phenotypically related to gain, and they translate the idea of how animals transform feed into gain. Well, selecting by this type of indices, we will find animals with higher average daily gain. Well, the second type of indices are related to the intake. So, for example, or the main one is residual feed intake. Well, in this type of indices, we will find efficient animals eating less by keeping the same level of performance. So, eating less, keeping the same weight and gain, right? So, in one side, we have animals with more gain, and in the other side, we have animals with lower gain, but similar, lower intake, but similar gain, right? So, yes. However, and this is the key point for me, however, genetic selection by these indices may have also negative consequences. For example, in this first case, we have animals associated to higher gains present also higher maturity weight, okay? Higher maturity weight mean that mature animals will have higher weight, which is associated to higher intake and higher maintenance cost in the farm. We're talking now about feed efficiency in the whole level, at whole farm level, so breeding farm and feedlot. Then animals associated to higher gains, they are also related to higher development of the hindquarter and therefore having or presenting higher calving difficulty, right? In the other side, we have animals presenting lower ingestion, which has been associated to a resource allocation. So we have animals taking energy from maybe other maintenance functions, for example, immunity and reproduction. And this type of animals have been identified like, how can you say, like with I will talk you specifically of each metabolism, energy and protein metabolism, but I just want to tell you that these animals with lower intake may have an allocation of resources and therefore taking energy of some vital functions like immunity. Well, in this point, I just want to keep you in mind that selecting feed efficiency is the future. We have to go there, but we have to take into account that feed efficiency as a multi-trait character is related to other reproduction, immunity, and robustness traits, okay? Well, as a consequence, it is very important to know which are the biological determinants associated to feed efficiency variations. First of all, in order to find the best trade-off between feed efficiency improvement and the rest of character we mentioned, robustness or reproduction. And second one, because to understand why feed efficiency is so different between animals raised in similar conditions. We have in the same farm, we can have animals eating the same type of feed, same breed, same period of the year, exactly the same farm and same farmer, and showing 20% of variation in feed efficiency between them, right? Well, well, between biological processes which have been associated to feed efficiency. In this graph, yes, I am showing which are those one mainly associated to RFI. RFI is the main genetic index used because of he's more heritable and more useful. I will tell you why. Well, these are main biological determinants explaining residual feed intake. We have, first of all, metabolism, who explain protein and energy metabolism. We have physical activity, digestibility, heat increment of feeding, and other parts, feeding behavior. Other parts I will tell you now. I don't want to be like so biologist, but I would like to explain you why some animals are more efficient than others, raised, as I told you, raised in similar or same conditions. Well, first of all, I will talk to you about digestion. It has been demonstrated that efficient animals have higher digestibility rates, approximately like more than 4%. Well, that may be explained because of a slower passage rate in the rumen. This could be explained because of feeding patterns. Efficient animals show higher amount of visits to the feeder than inefficient individuals, and also they eat less quantity of feed each time. So the digestibility is higher in these efficient individuals. But also this could be explained because efficient animals have lower or smaller rumens and a smaller amount or size of rumen according to the whole body. Also, we have higher ruminant efficiency, which is associated to rumen microbiota, but this part will be developed by my colleague Paul. So now we are going to talk about energy metabolism. And energy metabolism, I decided to divide it in whole animal level. We can see that energy metabolism at the whole animal level explains how the animal use the energy in each part in digestion, in metabolism, and in all little processes. For example, it has been observed that efficient animals produce less heat after the feed, so they expend less energy producing feed. Also, they have, according to other inefficient individuals, they have lower energy expenditure, because it has been also identified like efficient animals have lower, higher activity, sorry. So efficient animals have lower physical activity measured like with odometers, which means that efficient animals move less than inefficient individuals. And also, as I told you, they have a lower proportion of organs, especially rumen, liver, and this type of organs, specifically digestive organs, they have a higher energy cost. So having lower or smaller organs influence a lower energy expenditure. Well, and then we have the energy metabolism at cellular level, and it has been like also observed that higher or efficient individuals have a higher efficiency in creating or producing ATP, which is the energy resource, the main energy resource in metabolism. And finally, I will talk to you about protein metabolism, which is my main work, PhD work. I will tell you, when we talk about protein metabolism, we will talk mainly about amino acid catabolism, which is the division between amino acids intake into catabolism, so urine, or into anabolism, so gain, and also to protein turnover. Protein turnover is the continual protein synthesis and degradation of body proteins in the body, in the whole body, in each organ. So this process here, I'm showing you protein synthesis in blue, protein degradation in red, and protein gain in yellow. In this example, we can see two animals with the same rate of gain, for example, 200 grams per day. But however, we can see how these animals have different protein synthesis and degradation rates. So in this case, for example, efficient animals have lower protein turnover rates for the same rate of gain. This will impact a better nitrogen use efficiency because we will use less amino acids for protein synthesis and degradation, and also lower energy expenditure, because protein synthesis and degradation are costly processes. And here I would like to keep you in mind that efficiency is explained because of different biological processes, improving the capacity of animal to transform the feed. Main one is protein metabolism and energy metabolism, and also digestion. And also knowing which are the biological processes related to efficiency may help farmers or genetic selection to find the best trade-off between feed efficiency improvement and robustness. And thank you very much.
Thank you, Pablo, for your presentation. Now, from Teagasc in Netherlands, Paul Smith, who researches strategies for methane mitigation in ruminants, will show the relationship between feed efficiency and methane emissions. Paul works with Sinead Waters, who is the principal research scientist at the Animal and Bioscience Research Department in Teagasc, and both will be in the room table to answer your questions. You can start, Paul.
Super, thanks very much. Just want to double check you can all see my slides okay. Am I right in saying that? Slides are perfect, super. Well, thank you very much for the organisers for having us here today. My name is Paz. You saying something there, Lisa? Sorry, I can't hear you. Cool. You're on mute.
Sorry, Paul. We've got your the display settings need to be switched around so we can see.
Super. Yeah. Sorry. 2 seconds there now. Hold on. I'll get out of that connection, and this should hopefully. Sorry, just 2 seconds. Bear with me. Perfect. Sorry, guys. Display settings.
Yes, no problem.
No problem. Blank in slideshow. Perfect. Perfect. Is this a little bit better now, guys? Are you able to see it?
Perfect.
Super. Apologies. Super. Apologies about that, guys. Yeah, so again, thanks very much to the organisers for having us here today. So both Lisa and Pablo have given you a good overview of feed efficiency. So I'm just going to take things just a little bit differently and discuss the relationship of feed efficiency with enteric methane emissions. So my name is Paul Smith. I'm a postdoc researcher here at Teagasc and recently completed a PhD which looked at the relationship of methane emissions with the rumen microbiome. Perfect. So by way of an introduction to everybody, so as we know, ruminant livestock play a key role in global society, and that they are able to convert lignocellulosic plant matter into high quality sources of dairy and meat protein for human consumption. So I suppose the way in which ruminant animals do this is, it's said that they have a symbiotic relationship with the microbial population which lives in their rumen. So basically this relationship is mutually beneficial to both the host animal and the microbes. So the microbes that live in the rumen are mainly made up of bacteria, anaerobic fungi and protozoa. And these three types of bugs basically produce the enzymes required to break down grass and ultimately convert it into what's known as volatile fatty acids, which account for about 70% of the animal's energy source. The host animal then, so be it the cow or the sheep, the host animal would then provide the adequate environment for these microbes to prosper. So basically provide the right temperature and pH for these microbes to live in the rumen. I suppose during the process or during the breakdown of feed within the rumen, large amounts of hydrogen and carbon dioxide are produced as byproducts, and it's up to this other group of microbes known as the archaea, or more specifically the rumen methanogens. They basically get rid of this hydrogen and carbon dioxide from the rumen, and they do this by combining it to produce methane. So they get their energy source from combining hydrogen and carbon dioxide to produce methane, and ultimately, I suppose, from the animal's point of view, all this hydrogen has to be gotten rid of from the rumen, because otherwise it will prevent further degradation in the rumen. So why are we interested in methane emissions? So enteric methane emissions, so methane is the second most important greenhouse gas in terms of global warming. It is only second to carbon dioxide. It is 28 times more potent to the environment than carbon dioxide. And ultimately, I suppose, the whole process of methane generation within the rumen can divert some 2 to 12% of the energy in the animal's feed away from the animal. So about 2 to 12% of the energy which is contained in the animal's feed is ultimately lost to the environment in the form of methane. I suppose methane will last in the environment for roughly 9 to 12 years, after which it is then broken down to hydrogen and carbon dioxide. I suppose just to give you some figures and facts about methane emissions, so enteric methane emission, so about 40% of global agriculture's greenhouse gas emissions are produced from enteric methane, and this roughly equates to about 6% of global greenhouse gas emissions in total. I suppose in Ireland, due to in Ireland, about 19% of our national greenhouse gas emissions then are produced by originate from enteric methane emissions. I suppose then just finally, just to highlight, roughly 90 to 95% of the methane which the animal produces is eradicated or released from the rumen via the animal's mouth, and 5 to 10% of the remaining methane is then released out the back end of the animal. So one of the key drivers of methane emissions is the animal's level of feed intake. So if we think about this, the more feed the animal consumes, basically the more fermentation in the rumen, more hydrogen and carbon dioxide produced, and ultimately then the more methane which is produced by these rumen methanogens. And we can see that the relationship between feed intake and the amount of methane an animal produces on a daily basis is evidently clear from this graph here on the left-hand side. If we look at this other graph here as well, this graph was generated from data we collected as part of my PhD, and we can see, again, just to highlight the relationship of feed intake and methane emissions, we can see at 12 o'clock, when roughly midday, when animals were offered their feed, we can see that as the feed enters the rumen, there is this massive spike in terms of methane emissions, and again highlighting the relationship of methane emissions with an animal's level of feed intake. I suppose, as previously as Lisa and Pablo have identified, and when we're looking for more feed efficient animals, we're basically looking for animals that basically have a lower level of feed intake but ultimately maintain their level of performance. So in theory then, this begs the question, can improvements to an animal's level of feed efficiency, particularly its RFI, help to or potentially lower the amount of methane which an animal produces? So again, just to reiterate what feed efficiency is, it's the measure of an animal's ability to convert feed into animal product, and can be primarily represented in two different ways, be it as feed conversion ratio or as residual feed intake, or RFI. But for today's presentation, I'm just going to purely focus on the relationship of RFI with enteric emissions. And indeed, both traits, be it FCR or RFI, are both heritable traits, and ultimately the main thing which they do is they help to increase profitability on the farm. So again, this is just a schematic just to highlight the differences between a low RFI animal being an animal which is highly feed efficient, and the difference between a high RFI animal or an animal which is lowly feed efficient. So this data which I'm going to present, which was generated as part of my PhD, was recently, just before Christmas, published in the Journal of Animal Science. I suppose this data was generated at the Irish Cattle Breeding Progeny Test Centre in Tully, County Kildare, which is roughly about 3/4 of an hour outside of Dublin. And just to give you a bit of background to ICBF, or the Irish Cattle Breeding Federation, the ICBF is a non-profit organisation in charge of the recording and processing of all data in Irish cattle breeding. They operate a progeny test centre which performance tests over 600 beef cattle per year as part of our national bull evaluation programme, which includes progeny originating from a variety of different breeds and sires. For this, I suppose at the test centre, the standard operating procedure at the test centre is that animals undergo a minimum 100-day finishing period. So for the data generated at this project, we mainly looked at steers and heifers, and these animals consume a TMR, or a total mixed ration, which consists of 75% concentrates and 25% hay. At the test centre, animals undergo a 30-day acclimatisation period, after which they undergo then a minimum 70-day feed efficiency test period. At the test centre, then they record a variety of traits, including feed intake, conversion ratio, RFI, average daily gain, and also carry out some meat quality analysis as well. I suppose then, as of 2019, the test centre started measuring methane emissions from beef cattle. So the way that the protocol for measuring methane emissions is roughly, during this acclimatisation period, we train the animals to use the green feed system. I'll go through that system in a few minutes, and on the next slide, and how that measures methane emissions. And then after that, then the animals then go on to a 20-day methane measurement period as a minimum. And during the study, we operated at a ratio of 11 to 30 animals per green feed. And this is just an overview of the test centre. So the test centre has basically consists of 3 different sheds, which are all aligned with the cattle on test. And the majority of these sheds are now fitted with this methane measurement technology, which I will showcase in the next slide. So this is the technology we use to measure methane emissions as part of the trial. It's called the Green Feed System, and it's produced by a company in America called CLOC Incorporated. Basically, the way the unit works is each animal is fitted with an RFID, or radio frequency identification tag. So as the animal approaches the machine will identify the animal, and then to entice the animal to keep coming back to the unit, some bait feed will be dropped from a feed bin up the top of the unit. As the animal is standing at the unit and consuming its feed, basically what will happen is an extractor fan at the top of the unit here will suck all the air surrounding the animal's head, bring it up to a sensor up the top of the unit, which will then ultimately pass down to a computer down the bottom of the unit here, which will allow us to estimate an animal's level of methane and carbon dioxide output. But the system can also be used to calculate a variety of other gases, including hydrogen, hydrogen sulfide, and oxygen as well. And this is just to give you an idea of what the system looks like in real life. So down on the bottom slide down here, this is how we train the animals to use it. Basically, the animals were, during this acclimatization period, allowed unrestricted access to the unit. And then ultimately towards when the animals officially went on test, we then operated a system whereby one animal was in, one animal was out, and we fitted a gate ultimately to prevent more than one animal going towards the unit. So just some of the results that was generated as part of the study. So these results come from a population of 282 animals, which was collected over a 1.5 year period from 2019 to 2020. So we're looking at here, I'm not going to go through everything in too much detail, but for an animal that produced a carcass of 333 kilos, that animal was producing roughly just under 230 grams of methane per day. On the right-hand side of the graph here, on the slide here, again, we can see the relationship of DME, which is daily methane emissions, with dry matter intake. Again, seeing that relationship being consistent with the literature, that animals with a higher level of methane output tended to consume more feed. And I suppose this translates to, on average, for every kilogram of feed an animal consumed at the test centre, on average, each animal produced then 22 grams of methane. So 22 grams of methane was ultimately produced per kilogram of feed that the animal consumed. Again, highlighting the relationship of feed intake with methane emissions. I suppose then we also calculate RFI for all these animals, as well as the animal's daily methane emissions, and we've seen that, as expected, dry matter intake and RFI were positively correlated, which can be seen on the left-hand side here. But also we've seen that RFI, so residual feed intake, and the animal's level of methane emissions were also positively correlated. So in other words, this means that potentially by selecting animals for a lower RFI phenotype, we could look to hopefully then reduce the animal's level of daily methane emissions in future generations of cattle. I suppose finally, just before I wrap up, one question we're often asked is, will a reduction in methane emissions come at the expense of on-farm profitability? And based on some preliminary analysis, which was generated from this population of just under 300 cattle, basically this is the relationship of the animal's level of daily methane emissions with the terminal index, which is produced by ACBM, and these are just the traits which are included in the economic breeding index. We can see again that as the more profitable animals, basically as the animals become more profitable or have the potential to be more profitable on farm, we can see that these animals again had tended to have a lower methane emissions output on a daily basis. And I suppose if we look at the main thing which was driving these more profitable animals to produce less methane, we've seen that there was a positive correlation between the animal's daily methane emissions with that of its predicted transmittability for the animal's level of dry matter intake. So just to wrap up and just to conclude, daily methane emissions is strongly influenced by an animal's voluntary feed intake, and a selection for low RFI animals could then therefore have potential to reduce daily methane emissions. And ultimately, I suppose there is the potential there to reduce daily methane emissions without negatively impacting on-farm profitability. With that, I'd like to thank you all for your attention, and there are my details if anybody ever has any questions for me.
Thank you, Paul, for a great presentation. Now, with Lisa again, she will talk about how feed efficiency is measured. Lisa? We can't hear you.
Okay, great. So thank you. It's really great to be able to speak after Paul and Pablo, where we learned what a complex trait feed efficiency is, and where Paul came in and shared with us some of the studies that they've done at Teagasc and ACBM relating selecting for feed efficiency and methane. And so my company, Vytelle, we help producers use our technology platform to actually measure feed intake and calculate feed efficiency. And so I think, you know, after we've heard the following speakers, we realize that it is a complex trait and there's benefits for doing it. And so we measure it so that we can manage it. I can't tell you how many times I've been with customers and breeders who would say, you know, if I was just looking at these bulls, I would have never selected them. But by actually measuring them with technology, we're able to capture the data and we're able to identify those animals that are feed efficient and select for those. So we measure feed efficiency so that we can manage it. Pablo went into a lot of detail and Paul followed up about different measures of feed efficiency. And at Vytelle, we like to work with the residual feed intake. And here's my very high level summary about the difference between looking at RFI, residual feed intake, versus feed conversion ratio. What we're trying to do by measuring this and identifying those animals that have a low RFI, so a negative number, is to find those animals that have the same level of growth and production, but that they're eating less. So in this scenario, in a very simplistic view, we would always choose this animal because their level of growth and production is the same as the animal on the right. However, their feed intake is substantially lower. So that's really the goal of RFI. Whereas if we look at a measure of feed conversion ratio, so how much feed in versus how much production out, it is exactly that. It's a ratio. If you're targeting feed efficiency, I'm not really sure just by looking at feed conversion ratio if you'd be able to do that. However, looking at RFI, you can, and certainly those measurements will run in parallel. How we do this at Vytelle is we've got a technology platform, and that platform allows you to measure individual animal feed intake. So this, you see our intake hardware, and on the bottom you see our weighing hardware. And so when you run feed efficiency trials, you need to measure both animal feed intake and growth and production in parallel to, in the end, calculate feed efficiency. And so with the Vytelle system, we provide an entire platform where you get the hardware, you get the software, and the ability to look into the data on a daily basis if you're interested to monitor individual animals. And at the end of the trial, and this is important, you want to have the information and the insight off of the feed efficiency trials that you've run. So important when you're thinking about measuring and selecting for feed efficiency is that you've got access not only to the hardware to measure it, but the support and the insight at the end of feed efficiency trials. Just to give you some deeper understanding about the level of data that's being collected, because in the end, what we're trying to capture is the best phenotypic data to make decisions. And so important when we're measuring feed intake and growth and production is that we're really doing this in a standardized way. And at Vytelle, formerly known as GrowSafe, which you can see here on the hardware still, we have a system of feed bunks. And underneath these feed bunks are load cells. When the animal comes in through the head gate, as you can see here, they have an industry standard RFID tag. As the animal comes in, we know through the measuring of the feed bunks how much feed is actually in the bunk. When the animal comes in, the animal consumes, leaves the bunk, and then we measure the feed disappearance. And we measure that to a 3-gram resolution. And the system is sampling every second the animals are in there. And as I mentioned earlier, important is to make sure that when you're capturing this data, that it's done in a standardized way, it's audited to make sure that you're getting the best phenotypic data. A system like this would measure 8 bulls per feed intake node. The second hardware platform that we have is weighing technology. You can run feed efficiency trials using traditional chutes. However, we all know the stress and the labor and the uncertainty that pulling animals out of the pens and running them through chutes causes. And so Vytelle developed a way to continuously measure animals' growth and performance. And so we install these weigh platforms. So there's load bars underneath there in front of the water trough. And when the animals come to drink, the same way we do on the feed efficiency, they have an industry standard RFID tag on their ear. When they go in to drink, we're measuring every second and we're capturing a partial body weight on that animal. And you may say to yourself, partial body weight? Well, what we do through the years of experience and the thousands and millions of data points is we correlate the front weight, so the partial body weight, to a full body weight. And we do that by breed, we do that by sex, and we actually do that by farm site and calculate a full body weight. And so think about capturing if an animal comes 7 to 8 times a day, stands there for about 40 to 45 seconds, you can have 350 up to 500 weights on an individual animal per day versus running an animal through a chute every 2 weeks. So we are capturing a tremendous amount of data in a standardized format to allow us to be quite accurate. And if anybody's really interested in getting deeper in that, on the Vytelle website, there's some independent research that's been done about our partial body weight. This would be an example of a typical system that would be installed where you're able to run trials and tests on groups of 64, or you can also cut them into smaller tranches. Most of the technology out there today is very modular, and so you can start with a small size system and then grow if your needs increase. So again, feed intake nodes, weighing technology, all installed in the same pen, letting animals eat and drink non-invasively. I like this slide because people say, okay, well, how does that actually really look? How long does it take to run a residual feed intake trial? The Vytelle standards and protocols, are 49 days to actually run the trial, but we include a 10 to 14 day warm-up period to allow the animals to acclimate, to make sure the technology is functioning. And so there's always an acclimation period. Then the trial starts. It takes 35 days to capture the dry matter intake, and then we have to go longer, out to 49 days to actually get the growth curves on the animals. If you're not using continuous weighing and you're running animals through chutes, this number would be 70 days. So there's substantial value in terms of cost of running feed efficiency trials to using continuous weighing. And again, as I mentioned, throughout the trial, there's access to the data through the software, and at the end, what Vytelle provides is end of trial reporting so that you can make some decisions. I thought to take just one quick example here. to show you, going back to that point, that you actually can't see feed efficiency. So when you build your contemporary groups to run feed efficiency trials, you're going to have animals that are a similar breed, same sex, and all within the same age and weight at the start. And here you can see the animals on the left and the right have a similar weight. They have a similar predicted average daily gain. And then they have a similar expected feed intake. And so we build those groups, and then we start the trial, we run the trial. And at the end of this trial, this was a 74-day trial, we report what the actual feed intake was. And you can see here that that's about where the similarities end with these two animals. So you've got a difference of 2.8 kilos a day for the same level of growth and production. And that's what we're trying to do. We're trying to identify those animals that have a negative feed intake versus what we predicted that they would have. And if you extrapolate out what that savings of 2.8 kilos a day, if we just take a 0.3 euro per kilo, you can see just in that short period of time, that's a $65 savings. And so if you extrapolate that out across the breeding herd and into the feedlot as we finish cattle, you can see what that economic impact is for measuring and selecting for feed efficiency. Again, we are not advocating single trait selection. We need to have this as part of a balanced breeding program. But you can see here, this is an example of a feed efficiency trial that was run. And I just wanted to highlight out so you can actually see that variation that exists around feed efficiency. And here would be where, we would want to target those animals that have negative RFI, but their gain is still where we want it to be. A lot of people ask, which breed is more efficient than another? And what we see in our data is there's a plus minus 25% difference in feed efficiency across the board. Finally, I just wanted to share with you that over the years of work, we do curate the world's largest feed efficiency database. We've got 25 different breeds in our database, and we're providing, analytics and support around that. And so as a small producer, they say, well, how can I get started around feed efficiency? And well, this information is available on our website. And so working with partners that are already committed in testing and marketing feed efficient genetics through semen or buying bulls is a great way that we can expand the access to an important trait like feed efficiency. So in summary, feed efficiency matters because we can reduce feed costs, we can increase our profit, and we can work on the reduction of greenhouse gases. So with that, I'm gonna stop and I'll hand it back to the organizers. And I thank you very much for allowing me to speak today.
Okay, thank you, Lisa. It was very clear. And thank you, all of you, all the presenters. I think that you almost cover many of the questions we had in the beginning. So thank you, Lisa, Pablo, and Paul. But maybe there are some more questions to come from the people that is watching the webinar. So you can put your question in the chat. And while we wait the first one to come, I would like also to hear José Pais. He works in ACBM, and he is responsible of the breed plan in Portugal in a local breed, Mertolenga. So I would like to hear your experiences. What can you tell to other farmers that would like to start with this trait, measuring this trait? So I would like to hear your opinion or your experience.
Yes, Virginia, thank you for having me also. First, I would like to compliment every speaker. Really nice presentations and interesting ones, and with really useful and important information. Well, our experience is since 2018, we installed 9 units of this kind of system. I think similar system for compared with what Paul shows. I think it's the same company. We have a small amount of data about residual feed intake for Mertolenga with this kind of units to control the total feed intake for each animal. But with the, well, at least with almost 4 years of working, we already confirmed the data that Lisa and Paul presented. There are low efficient animals and high efficient animals, and between those two extremes can be really a big gap. So I would like to say that feed efficiency, it goes along with another word that is production efficiency, and we have to be more efficient in production. So that's why I think this trait can be, I don't know, but probably the most important of any kind of breed plan for any kind of breed around the world. So not only for the production efficiency as economic results, but also, as Paul really shown us the importance of lower emissions of methane. Well, there's a kind of difficulty to use this equipment. Lisa just put it right on. It's huge. It's expensive to install an equipment like this. So a single beef farmer can't work alone. He has to work with some companies like Vytelle or Teagasc or whatever, because alone it's really difficult. Well, that's all. I think that's the for now. That's my statement for now.
Your view. Thank you, Jose. Mimi, do we have some questions in the chat box?
Yes, we've just had a question come in. I will just sort it out now. Sorry, just trying to get it up. So we have a question here from Pablo, who asks, are more efficient animals seen to eat less, have higher digestibility and lower passage rate? These traits can be related, but what is the cause and what is the effect? i.e., what came first, the chicken or the egg?
Yeah, I totally got you. Well, in my PhD, we really wanted to ask this question because actually we don't know. Okay, I will show you my opinion, right? Talking about residual feed intake, okay, there are some papers, some works talking about animals. Maybe they have just higher appetite, right? Just higher appetite, without talking about metabolism, body composition. Well, in this type, if we take just this type of work, we could say, okay, higher appetite, higher dry matter intake, higher or higher size of rumens, and this is going to impact the passage rate or the higher or lower digestibility. So we have appetite, we have body composition itself, we have genetics. So for example, talking about protein turnover, which is my topic, protein turnover and genetics, because genetics explain or is associated to protein turnover. A higher protein turnover, higher protein synthesis, higher protein degradation is also, or has been also related with higher amount of organs, the digestive organs, and a change in body composition. So which is the main factor explaining this digestion? I don't know. I don't really know if it's genetics, if it's body composition, if it's appetite, of if it's rumen microbials, because in this size I am much more expert. But talking about digestibility and just taking the main works talking about digestibility, it has been observed that it could be explained because of smaller rumens, and different feeding behavior. So this is like in humans. So if we eat higher, if we eat more times, we say it in humans like 6 times less quantity, we will increase digestibility and we will increase our metabolism. So in animals it's similar. So efficient animals eat less, but they eat less amount in the whole day, but they eat more times and few smaller quantity. I don't know if it's clear, but your question for me is a key question, but I can give you, yes, it's genetics, or yes, it's body composition.
Okay, there is here another question from Manuel that I guess is to Paul and Sinead. How rumen, let's see, how rumen microbial population manipulation could contribute to feed efficiency and decrease of methane production? It would be possible to do it at farm level?
Hi, Virginia. Just maybe to come in there, we're doing a lot of this work in Teagasc and internationally. I don't think that this will be done at farm level. I think this is going to be done at a research level, and that the information will be used for 2 ways. First of all, in a breeding program, it can be used rather than, as Lisa described and Paul described, that the long and expensive RFI trials that we run. We could find proxies for RFI for basically to be able to predict if an animal is going to be highly feed efficient or not highly feed efficient or inefficient per se. So we're using, say, for example, rumen microbiology to help us in that way. Because if you think about it, in terms of digestion, so rumen microbes are critical for the digestion of feed, but also as a byproduct of that, the methanogens scoop in, and they're intrinsically involved in the production of methane as a byproduct of that process. So really, what we're doing is trying to understand the rumen microbes involved in RFI and also in feed efficiency, and also in methane production. And Paul has another paper following from the paper he presented to here today on that's going to be out in the next week or two to supplement that work. But as they were saying, it's either going to be involved as proxies which we can then use in breeding strategies, but also to help us to improve RFI potentially as a probiotic or adding something to a feed to make animals more feed efficient. So that will serve as 2 purposes, in my opinion. Understanding the rumen microbiology behind digestion of feed, as well as the production of methane, is very important because you can use it as supplementation strategies as well as breeding strategies.
Okay, thank you. Here I have another question from Donald. He said that some beef bulls that perform very well in terms of RFI grow at a slower rate, so take longer to finish. How can you avoid this in a breeding program with RFI?
I mean,
I don't know
Virginia, I would just jump in. I mean, we get that question often. Again, I think there's no magic pill, right? Breeding cattle, single trait selection is not the way that we want to go down. I mean, we've seen what's happened on the dairy side when we focused on single trait selection. And so it's got to be part of a balanced breeding program. So you can, RFI, the beauty of it is that it's independent. So it means you can select for RFI and you can also select, for things like growth. So I would respond to the question in that way. I don't know if anybody else on the panel has something to add.
Yeah, I would agree with Lisa on that. Really, it's not recommended to have single trait selection. And also, of course, like the residual methane trait Paul presented in his presentation, residual feed intake is independent of these other traits of weight and so that's why growth rates. That's why we use them.
Okay, here we have a question for Lisa from Joao. In your experience and data collection, how are females compared to males in food efficiency?
Yeah, again, I mean, our goal is not really to pit females against males or one breed against another. And as I mentioned, the spread is dramatic. So it's really plus minus 25% is what we see. Again, the importance of measuring for feed efficiency. And I know that, I also know that, there's been a lot of comments about the expense of it. And I think, that's the beauty of our industry, the collaboration around it, that if, there are test stations, there are breed associations like José's that get involved and offer those services. And, what I've seen happening, especially in Europe and smaller, because the systems are smaller, is a few breeders get together and invest in the technology. So I think having a fresh look at the economics is important. And I mean, just the savings alone that I demonstrated covers the cost of testing one animal.
Mm-hmm. Thank you, Lisa. Here, a question for Pablo. Do you have hormonal profiles between animals when you compare the protein synthesis in efficient and less efficient animals?
I have it. I have insulin growth factor, and I have also insulin and blood metabolites. Well, in my work and also in some work of my colleagues, we found that efficient individuals have lower insulin levels, which could be explained because of lower intake, but also talking about protein synthesis and its relationship. There are many works starting talking about a possible insulin resistance in inefficient individuals. So maybe they eat more, but the insulin response is not as higher as in efficient individuals. So that insulin with amino acid and glucose and other blood parameters, but mainly insulin, is associated to protein synthesis. If insulin response at cellular level is less comparing with the eating rate, we could see in my work, for example, in my work, this question is quite difficult, and some biological questions talking about RFI are difficult because I will explain you a little bit. We have to take into account we're comparing animals with different intake level, so we can't compare an efficient and inefficient individual because they have different feeding level. But in my work, I decided to give the same quantity of feed and analyze metabolism. In this case, I found that efficient individuals had a higher level of insulin, which means that maybe efficient individuals take or absorb, or their response of insulin and metabolism is higher according to the same rate of feeding. I don't know if it's clear, but
okay, thank you. I'm going to the next question. It's a big question. If someone else wants to talk about what Pablo said, you can also do it, okay? If not, I continue. So from Alessandro, he said that I think that in a period when sustainability is a vital topic, it would be important to investigate on which genetic types are more efficient in using low quality feeds that are less needed in human nutrition. What do you think? It's the question from Alessandro.
I mean, I would jump in there, Virginia, and say, I mean, I think we're already at an advantage to other animal proteins because, you know, cattle graze on land that would not otherwise be suited for crop production and so forth. So, and I would agree with Alessandro's point and question. I mean, this is the beauty of having this kind of technology and what some of the nutrition companies are doing, some of the research organizations are like Pablo and Paul and Jose are doing. So I don't disagree. I mean, it's there's a lot of factors coming into play.
Yeah, if I can add, oh, sorry. Yeah.
Sorry.
I was just going to add, it's an important point for us because in Ireland, we're a pasture-based country. So it's very important for us for any, say, genetics in terms of selection for RFI as part of a multi-trait index. We would basically have to validate those on pasture-based systems so that we can use these genetics basically in our pasture systems. So I totally agree with what that comment in the question, because you know that would be very important for countries like Ireland, where you know importing feed is very expensive, particularly in the current climate. So you know it's very important that all of these work in a pasture-based system and the selection process. So yeah, I would agree.
So I think this question is related to the next one. Yeah, Pablo, do you want to say something?
Yeah, just a little point. Here in France, we had this problem because actually genetic companies usually take better bulls and they give them like a concentrate for reproduction animals or best bull animals. But you know, you are selecting animals or you are categorizing animals eating a concentrate. So then we find in the field and in herd, in females eating grass, we find a difference between what we expect according to genetic index we use and what we observe. And also according to residual feed intake, we can also observe that animals selected with a corn-based diet or a concentrate diet, they are maybe not efficient eating a low quality diet like a hay or lower quality diet. So this is a point, this is a key point. At least here in France, they are genetic companies that are working on select animals when they are fed with not lower quality diet, but not also concentrate, not just concentrate.
Yeah, it's a really good point, Pablo, and it's the same for us in Ireland. And we have to think here, we're talking the whole time about feed intake, but it's not just the intake of the diet, it's the constituents of the diet. So not just for concentrate, there's other types of diet, be it a TMR diet or a grass silage or you know a pasture-based diet. So that is a very important point. It's something that Paul and I actually discuss regularly. You know, in terms of the selection for RFI, and of course methane as well. You know.
Okay, so I think this is related to the other question, that is to know if it's possible to measure this in a pasture-based system. So I don't know if Vytelle is thinking in a machine or in something to measure, or for the moment only we can measure rations.
Yeah, I mean, Vytelle has a few research collaborations where we're actually attempting to do this. You know, as you can imagine, measuring feed intake on pasture is not the easiest thing to do. You need a lot of graduate students that are keen to help you along the way. But we do have a few collaborations where we are practically doing this. And we also have, we get this question a lot about measuring in dry lot and how does that translate over into pasture. And what we do, we've got 160 individual sites worldwide in different conditions with different cattle. And, time and time again, our partners, private breeders, will tell us, that have been measuring and selecting that they are seeing those animals, those genetics. They're doing better in drought time. They're doing better when pasture quality is down. They're feeding less supplementary hay to their cattle. So we have the science going, but we also have the practical experience of people that have been doing this for 10, 15 years.
I might just actually add a point there based on what Lisa was saying, just in terms of measuring feed intake at grass. One of the bits that we did find in our research in Tully is that we're starting to see a strong correlation between an animal's level of carbon dioxide output on a daily basis and the animal's level of feed intake. So with that machine that we'd shown there in the presentation, the green feed system, as I said, that machine also measures the animal's level of carbon dioxide as well as methane emissions. So in theory, although this was only confirmed in our indoor feeding system, I suppose at pasture, if we could also confirm that this level of the animal's level of carbon dioxide again did have a strong relationship with an animal's feed intake, it might maybe perhaps be able to act as a proxy, I suppose, as such for an animal's level of feed intake. So in theory, that would make this research a lot easier to be carried out at pasture instead of having to have scenarios where graduate students like I had to go out and then measure the animal's level of feed intake, as Lisa said.
Yeah. And the other thing is we have pasture-based green feeds now as well, so we can measure methane, but we need to be able to measure intake, of course, to complement that process.
Yeah.
Okay.
So hopefully, if that correlation stays favourable, that could be an answer.
Okay, thank you everybody again, and thank you to the audience. I think that there are no more questions. So I would like to ask also the audience to complete a survey, a short survey, to have a feedback or opinions, maybe more questions, or to say if you like or not the webinar. So you have the link, and so I give the word to Mimi now that she will say goodbye.
Thank you very much, Virginia, and thank you to all of our speakers that have joined us this afternoon. It's been a pleasure having you, and really, really interesting to listen along, and I'm sure I speak for the whole audience when I say that. We'd also like to thank all of our audience for attending. It's really great to have you all here. And just to let you know that we will be presenting more webinars in the future. There's another one coming up in a couple of weeks' time, and regular webinars will be taking place over the next coming months. So please do keep an eye on our social media channels as well as on our website. And of course, we will be sending emails out as well via our mailing list. So that will have more information about the webinars there. Please do make sure to follow us on social channels and check the website regularly for news and updates from the project. And also please do take a look at the BovINE Knowledge Hub. This is a free online platform which is filled with lots of research innovations and good practices that have been sourced by the project. And it's all up there, all completely free of charge and fully free to access for anyone. So you can access that through our website, but otherwise it's hub.bovine-eu.net. So once again, thank you to everybody. It's been a pleasure having you all here, and have a wonderful evening. Thanks very much then. Goodbye.
Thank you.
Thank you.
Goodbye.
Bye-bye.
Bye, folks. Take care.